Hey guys, welcome back to Coding Simplified. So I'm really excited about today's video because today we're going to do something a little bit different, and I'm going to be showing you how you can code anything. Now this is a topic that I've actually never heard talked about on YouTube. It's something that I picked up when I was getting my computer science degree. So what I'm going to do is I'm going to explain the idea, and then I'm going to give you an example of using this idea in action. So many of you guys are probably familiar with pseudocode, but for those of you who aren't, pseudocode is a way of writing out code in words that make sense to us in English, and then translating those later into code that the computer understands. This technique I'm going to share with you is going to allow you to start out with concepts in English and keep expanding them until you have a complete code. Now, something that a lot of beginner computer programmers get stuck on is worrying about the specific language. But guys, that's not really that important. The truth is, you can look up a lot of the syntax for any of these languages on Google. What's more important is to develop a foolproof method for starting with an idea and developing it into the final code. So today I'm going to be using Python to write out my examples, but you can use this technique in any language that you choose. So let me explain this idea a little bit better. The main idea is that you write in English the steps that need to be taken to accomplish whatever goal you're trying to achieve. So for example, if we're baking a cake, we might just write something like bake a cake. And if it's something that we're doing, we're going to put parentheses because it's like we're calling a function. Now, I did a couple videos on functions if you want a reminder on how those work. Okay, so now that we know that we're going to be baking a cake, we go inside the box of the function and start thinking of the steps that we need to take in order to bake a cake. So maybe we need to gather the ingredients, and then maybe we need to mix the ingredients, and then we need to cook the ingredients. And then that's it. So now that we have this written out, we can go back before here and define what it means to do each of these subcomponents. And I'm going to put my keyword for a function there. Then I would go back here and define what it means to gather the ingredients. Maybe you get the flour, then you get the sugar, then you get the butter, on and on. Okay, and you do that for each of these functions that I called here. So I'd have something here for mixing the ingredients, and I'd have something here for cooking the ingredients. Okay, and then each of these subcomponents of this part, I'd go to an earlier spot in the code, and I'd define what that means to get flour. And keep working backwards until everything's defined, and then you can start testing the code to make sure it works. Now, the nice thing about this technique is that it actually forces you to write good code. It forces you to think about what you're doing in sections, group things that are related together, and create functions for each individual action. So using this technique helps promote clean code. So now that I've explained the basic concept, let's do a more interesting example. I thought we could try to replicate the game Hangman. Now, I haven't written out the code for this beforehand. I'm just going to be using this technique that I'm sharing with you from start to finish and showing you how this technique can turn any idea you have into a final running piece of code. So for those of you who aren't familiar, Hangman is a game where the computer picks a random word, then the user keeps guessing letters. Now, if the letter is in the word, all instances of that letter are revealed in the display. Otherwise, another piece is added to the Hangman stick figure. And then when all the pieces have been added to the Hangman, the user loses. But if the user guesses all the letters correctly, the user wins. So this is the basic idea of how Hangman works. And notice, this is all written out in comments in English. So this is still in the pseudocode stage. But let's start turning this into actual code. So before we think too much about how we're going to really implement this, we can start calling functions that we haven't defined yet, that are named based on what we want them to do. So for example, here, I want the computer to pick a random word. I could say pick random word and call it like a function, even though it hasn't been defined yet. Okay? User keeps guessing letters. Now the word keeps implies it's going to keep happening over and over. So instead of just saying user keeps guessing letters, we could modify this to say as long as the user hasn't lost or won, keep guessing letters. So all we did is we took this original idea and turned it into a condition. And if we do that, we can turn this into a while loop. So now I can say while user hasn't lost and user hasn't 1, as long as the user hasn't lost and the user hasn't won, the user is going to keep guessing letters. If the user wins or loses, we're going to have to break out of this loop. So now that we know this is going to keep looping, we can focus on the part that says keep guessing letters. So I could even write something like guess letter, because that's what we're going to be doing in that step. And I go down to this structure. If the letter is in the word, well, that sounds like an if statement to me. If letter in word. Now we haven't defined a lot of these things yet, so we're going to have to go back and make sure that we write in what letter is and word is. But for right now, we're just writing it out so it makes sense to us. So if the letter's in the word, we're going to display letter. We'll figure out what that means later. Else, we're going to add to the hangman. Now at the end of this loop, we have to check if all the pieces have been added to the hangman or if the user has guessed all the letters correctly. Now, if you stop and think about this for a second, the only time all of the pieces could be added to the hangman is right after we add a new piece to the hangman. So we can actually move this up here. Likewise, the only place that the user could guess all the letters correctly is after they guess a letter correctly. And then maybe at the end, after this loop is done, we could say, if the user won, print congratulations. Else, which means they lost, you can say, I'm sorry, you lost. Okay, so this is starting to look more and more like code. So let's go back and start defining some of these functions that we haven't defined yet. So the trick is you have to go back before the function's defined, and then write def, and then the name of the function that you chose. So here we're defining pick random word. So we can make this more advanced eventually, but just to test it out, we can create a simple list of words with a few words that we've chosen, like test, pasta, bologna. And then we need to choose a random word from these words. So here's an example of where if you don't know how to do something, you can just Google it. So I typed in Python random integer in range. And right here, I got this handy piece of code. From random, import randint, and then you can use that random int in a range between 0 and 9. So I'm going to take this piece of code and I'm going to modify it. Now I'm importing from a library called random this functionality that allows me to use a random integer. And I actually want to use a random int in the range 1 to the length of my list. So let's bring this down here, and we actually don't even need to print it. So I'm going to have it going from 1 to the length, which is the keyword for length is len. That's another thing you can look up if you didn't know it. And this is going to be the length of this list. Now this list is length 3, so this is going to be range 1 to 3. Now we actually want to subtract 1 from this because when we use lists in Python, the first element of the list is actually element 0, and it goes from 0 to 2. So now I'm going to say index equals this random number that we just came up with. So what this is going to do is generate a random number. Now, why didn't I just write 3 here? Well, if we added on a word to this list, this will actually adjust. Okay? And now we need to pick a word, so we can say word equals, and then we go to the list of words, and we take the word at that index. And then at the end, we're going to return that word. So this will pick a random word from this index. Now, in order to make this more useful in the future, I'm actually going to define words outside of this function. That way we can edit it freely, and then we're going to pass it in to the function. So now when we call it down here, we have to call it. And let's move that down here right before where we call it. And I can expand this to say, computer picks a random word from the words list. Okay, now let's go down here. While the user hasn't lost, and user hasn't won. Well, these sound like Boolean values to me. So we could have a value that says whether or not the user won or not. So I could say user lost, and let's start that out at false, because at the beginning of the game, the user hasn't lost or won. So then user won would also be false. So here, instead of saying user hasn't lost and user hasn't won, we can replace these with not user lost and not user won. We're just translating this into the language of the code. Okay, now the user is going to guess a letter. So we have to define this somewhere. So we can say define what it means to guess a letter. So what's going to happen? Well, we want the user to be able to input a letter. So if you want user input, it's as easy as saying input. And we'll say that our guess is equal to whatever the user inputs. And this is going to be a string. And then we're going to return the guess. And now, since this returns a guess, we're actually going to say guess equals whatever this returns. So now, whatever the guess that the user gave here was, we're going to have access to that over here. So now we check if the letter is in the word. So what is the word? Well, we already did our pick random word function, and that did return a word. So we have to do the same thing as we did with our guess letter function. And we have to say word equals whatever this returns. So now the word it returns from here is actually going to be accessible throughout the rest of the code. Now I said if letter in word, but let's change this to if the guess is in the word. Okay, so now we get down to display letter. So the thing this has been missing so far is something, first of all, to keep track of how many guesses the user has had. And then also eventually we're going to want to have some kind of display for the hangman. So let's start taking care of those right now. Let's define all of these things outside of this while loop. So let's have something called word display, which is going to start out displaying blanks when the user hasn't yet made any guesses. And then as the user starts correctly guessing letters, those blanks are going to be filled out. So we're actually going to start it off just completely blank. And at the beginning of this loop, every time, we're going to display all of the things that need to be displayed. So we're going to print the word display, which is going to start out being blank. We're going to print the hangman display, and that's it for now. So we need some kind of function that's going to initialize this word display into the amount of blanks that matches up with the random word that the computer picked. So we know that before this starts, we're going to want to initialize word display, and then we're also going to initialize the hangman display. And we can define the hangman display up here too, and start that off as a blank as well. So I also want a variable to keep track of how many guesses the users had. So I could say number of guesses is going to start out at 0. So now that we've called these two functions, we can go back and define what they actually mean. So I can say define initialize word display, and we can come over here and define initialize hangman display. So our word display is starting out as a blank string. We want to create a string of blank spaces that's based on how long this word is that the computer picked. So we could do something like for letter in word. So for every letter in this word that the computer picked, we're going to add a blank space to the word display. So word display equals whatever it was before plus a blank space. So I've decided to save on time. We're actually not going to worry about the hangman display today. We could look at it in a future video, but it's going to take too much time to work through that right now. And let's say that the user gets 10 guesses actually. So I'll write that right here. User gets 10 guesses. So we've initialized the word display and we've called that. So now the word display is going to have as many blanks as there are in the word. So let's keep going down here and see what else we need to do. So if the guess was in the word, we want to display that letter. Instead of calling this display letter, let's call it something like update word display. And we're actually going to want this to return the current version of the word that the user's guessed so far. So let's say current word equals update the word display. So let's define update word display out here. And we're actually going to pass in the letter that we guessed. And we're going to put that over here. So over here, it's an argument, and then it's a parameter over here. So basically what we're going to do here is we're going to go through the letters in the correct word, and then if the current letter is equal to whatever the guessed letter is, then you're going to replace the blank with that correct guess. And so then we really don't need this version of the current word, really, because the information about what the current word is stored in the word display. And that's it. One of the other nice things about this method is that if you use comments to figure out what you're doing, and you use function and variable names that are named after what they're supposed to be doing, then your code is going to be super readable at the end of this. You don't have to go back through, figure out what you did, and add comments. Your comments are already going to be there. So this is a very efficient way to code. So we could say for letter in our correct word, then this looks like an if. If letter is equal to guess. Now the way I'm going to actually implement this is by, instead of updating a certain word, I'm going to create a new word, start it off as a blank. If we're replacing the blank that was there with a guess, we're going to say new word is going to be itself plus whatever guess was. Otherwise, the new word is going to be whatever it was in the current word display. So I need some kind of index to keep track of this. Outside of here, I'm going to say index is going to start out at 0. At the end of this loop, the index is going to be incremented by 1, and then the new word is going to be whatever the letter at that index was in the current word display. So that's going to be word display at that index. So this will update the word display. Okay, so that's looking good. And now we have to update our word display. So now we're going to say word display is going to be equal to this new word that we created. So the new word was created out of the old word display, but then we replaced correctly guessed letters with that correctly guessed letter. So here, let's go down here, see where we left off. Okay, so if the user guesses all the letters correctly. So how do we know if that's true? Well, we just have to look at our word display and see if it matches up with the word that the computer picked. So we could say if word display equals word, which is what the computer picked, then it says the user wins. And we're going to say user 1 is true, which is actually going to break us out of this loop when we get up here. I'm going to put this comment up above the piece of code. Okay, otherwise, we have to add a piece to the hangman. Now, we're not going to worry about the actual stick figure, but we are going to add to the number of guesses that we have. So remember, we have this variable up here that says number of guesses, and we're going to give the user 10 guesses. So let's define add to hangman. What's nice is that if we're going to expand this later, we could actually add the part about displaying the hangman here. It would already be set up for us to expand. So all we're going to do is say number of guesses is going to be incremented by 1. We're incrementing the number of user guesses. Okay, and then we have to check if the user lost. So let's expand on what that means. We're going to say, i.e., when user has made 10 guesses, the user loses. So we could say if number of guesses equals 10, then we lose. User lost equals true. Okay, and then we come here and if the user won, let's change that to if user won. We already have another variable that has a very similar name. If user won, otherwise they lost. Let's try this out. I bet I forgot something. Okay, so now we get to see how we debug this. So in our initialize word display, we have this error that says local variable word display is referenced before assignment. So let's go up and check that out. It's actually normally a good idea to test these as you're going. So let's make sure that this word is being picked correctly. So I'm actually just going to say print and then word is and then what the word is. Let's try running this again. Word is baloney. Okay, so our word is correct. This looks good. We define what it means to guess a letter. So it seems to think that this is a local variable. We could fix this by passing it in as an argument. We can have it accept a parameter called word display, and then we could have it at the end return word display. And then here we could say word display equals whatever this returns. Let's see if that fixes that part of it. I forgot to pass that in as an argument. Let's try this out. Name hangman display is not defined. Okay. I forgot that we took out the hangman display, so we have to get rid of that. Any other problems? Oh, so it's saying our word is test. So let's see. If I guessed an E, okay, what's the problem here? Local variable word display referenced before assignment. It's the same problem from before. So let's go to update word display. Let's also pass in the current word display. And then we have to return the word display. So then when I go down here to update word display, we have to say word display equals update word display of guess and our current word display. Word is pasta. Let's guess an A. There we go. We got blanks and we have A's where the pasta is. Let's say S. Okay. But here, let's say I got a bunch of wrong guesses. E. Oh, so we have a problem in add to hangman. Number of guesses is referenced before assignment. Okay, so we're going to have to do the same thing as we did with the word display. So for add to hangman, we have to take in something called number of guesses. And then we'll return number of guesses. So when we call add to hangman, we're going to include number of guesses, and then we're going to say number of guesses equals that. This is just a stupid problem with the syntax, but it seems to be working now. Let's try it out. Okay. There's 2 T's in there. Let's guess a wrong number this time, though. X. Okay. Not correct. It wasn't in there. Y wasn't in there. G wasn't in there. Just keep guessing the same one over and over. And eventually, it's going to break out, and it's going to say, I'm sorry, you lost. So we could get fancier if we wanted and do stuff like displaying all the current guesses or checking that the same letter doesn't get guessed twice, or displaying the hangman itself. But the very basic version of this game is currently working. Let's try it again. Okay, the word's pasta this time, so let's pretend that I'm guessing this correctly. Congratulations. Well, there you go. It's a working basic hangman game. And I developed it from scratch just using the secret technique. So to recap, the secret idea that I'm sharing with you is to start the code by just writing out in English what needs to happen. And then you go and you expand out all the steps that it would take to achieve that bigger step. And you keep doing that over and over, expanding out further and further. And at the end of it, you're going to get code that's full of useful comments, full of variables and functions that have easily readable and useful names, a code where all the functions are separated by what they do, and a code that works overall. Honestly, this has been one of the most helpful concepts that I've ever learned in computer science. So I encourage you to go out there, start with an idea, start writing it out in English, and you can look up how to do the specifics along the way. But if you follow this advice, you'll be able to code anything. Let me know if you have any questions or suggestions down in the comments below. I know this is going to be as helpful for you as it was for me. So if you enjoyed this video, make sure to like, subscribe, and tap that notification bell. I'm going to be uploading every week, so you don't want to miss any of these videos. Thanks so much, guys, and I'll see you next time.